OACB is a parallelogram. O to A is the vector A, and O to B is the vector B. So because it's a parallelogram, that means that this over here is going to be B as well, and this over here is going to be A as well. The points M, S, N and T divide OB, BC, CA and AO in the ratio 1 to 4 respectively. So this is one part, this is 4 parts, this is one part, this is 4, this is one part, this is 4 parts, and this is one part, and that's 4 parts. The lines S, T and MN intersect at point D. Part A, express M to N in terms of A and B. So M to N is this, which I'm going to think of being the same as M to B plus B to C plus C to N. Now the M to B, that's going to be 4/5 of the vector B. The B to C is just vector A. And the C to N, that's 1/5 of B, but in the opposite direction. So it's going to be minus 1/5 of B. And we can then neaten this up a little bit by collecting up the like terms. The 4/5 B minus the 1/5 B is 3/5 B. And that's my answer for M to N. So let's now move to part B of this question, where we want S to T. So S to T is that, which I'm going to think of as being S to C plus C to A plus A to T. Now the S to C, that's 4/5 of the vector A. The C to A is just minus B, because it's the same size as B but in the opposite direction. And then the A to T, well, that's 1/5 of A but in the opposite direction. So it's minus 1/5 A. And again, we can tidy that up a little bit. The 4/5 A minus the 1/5 A is 3/5 A, and we've still got the minus B there. So that's my answer for part B of this question. Now for part C. We need to show that the lines MN and ST bisect one another. So if that's the case, then if MN bisects ST, then I know that S to D is going to be half of S to T. So SD is equal to half of ST. Now, I want to show that's the case, so I'm going to say S to D is equal to lambda ST. And I want to hopefully show that lambda is a half. Similarly, if SD bisects MN, then M to D is going to be equal to half of MN, of the whole thing. So again, I want to hopefully show that MD is equal to half of MN. So I'm going to say it's mu MN for now. And then again, I will hopefully show in a minute that mu is a half. Right, how am I going to do that then? Well, I'm going to choose a vector in the diagram that I can consider in two different ways, one involving the MD and one involving the SD. And that vector is going to be O to D. Doesn't have to be, you could choose other ones, it's just the way I'm doing it. So O to D. I could think of that as being O to M plus M to D. O to M, I know that's 1/5 of B. And the M to D, I know that that is mu Mn. And Mn, we worked out in part A of the question. So that's one way of me calculating O to D. It's not the only way. I could also say that O to D could be the same as O to B plus B to S plus S to D, which I know will involve the other fact that I was trying to show. Right, so the O to B is just B. The B to S is 1/5 of A. And the S to D, I know is lambda times S to T, which I worked out in part B of the question, is 3/5 A minus B. Right. These two vectors are the same thing. They both represent O to D, which means that this should be the same as this. And we're going to compare them now. We're going to focus first on the A terms. Then we'll focus on the B terms afterwards. So the A terms for the first expression, we would have mu times A. For the second expression, we've got the 1/5 A here and a lambda times 3/5 A here. And those terms should be equal to one another because they represent the same vector. If we now do a similar thing with the B terms, so the B terms for the first expression, we've got the 1/5 plus mu times 3/5. And for the second expression, we've got 1b here and a lambda times minus 1 there. So the 1b and the lambda times minus 1. And right, we've now got simultaneous equations to solve. So let me just create a bit more space. So, solving these simultaneous equations, I'm going to take this term here that's equal to mu, and I'm going to substitute it in here instead of the mu there. So I'm going to get 1/5 plus 3/5 times the 1/5 plus 3/5 lambda equals 1 minus lambda. Expanding those brackets out, the 3/5 times the 1/5 is 3 over 25. The 3/5 times 3/5 is 9 over 25 lambda. These fractions are looking a little bit awkward, so let's multiply everything through by 25. The 25 times 1/5 is 5. That's now just a 3. That's now just a 9 lambda. The 1 times 25, the 25 times lambda. If I then, the 5 plus the 3 is 8. If I then subtract the 8 from both sides, so the 25 minus the 8 is 17. I'm then going to add the 25 lambda to both sides. The 9 plus 25 lambda is 34 lambda. So 34 lambda equals 17. Divide both sides by 34. 17 divided by 34 is 1/2, which was what I wanted to show. Remember, I wanted to show that SD was half of ST, so that ST had been bisected. Now I know lambda is 1/2, I can substitute that back into this other equation here to work out mu. So mu is 1/5 plus 3/5 times 1/2. So 1/5 plus 3 over 10, which is 5 over 10, or 1/2, which again is what we needed to show that MD was 1/2 of MN, so that MN had been bisected. So I can now just say SD equals half ST and MD equals half MN. So ST and MN bisect each other. And we're done.